So in this lecture we're going to look at the second of Newton's laws, which links a resultant force to an acceleration for a particular object. Now we've already said if there is a resultant force on an object, it will accelerate. We established that in Newton's first law. But his second law describes two of the main factors that affect the size of the acceleration that we would see. The first of these factors is the force itself, the size of the resultant force. If an object is the same mass, if you increase that resultant force, you will increase the rate it accelerates by. That kind of makes a bit of sense. The other factor that you mentioned was the mass of the object. If you keep the force the same and you increase the mass of the object, you'll get a smaller acceleration. So his second law shows how the resultant force applied, the mass of the object, and the acceleration you see are all linked together. So we'll just put that into a real life concept. We've got two vehicles here. We've got a small car and we've got a large van. And we're going to imagine that both of these vehicles are experiencing the same size resultant force. So there's a resultant force on the car, there's a resultant force on the van. Now if we say the car has a mass of 1,000 kilograms and the van has a mass of 4,000 kilograms, Newton's second law says that if they experience the same force, the object with the greater mass will see a smaller acceleration. So in this case, our car would have a larger acceleration than the van. So they have the same resultant force applied, but because the van has a greater mass, it experiences a smaller acceleration than the car. If we wanted these objects to experience the same rate of acceleration, we'd actually have to really increase the size of the force on the van, and that would result in an increased acceleration. This is Newton's second law. It relates those three variables: the mass of an object, the resultant force applied to the object, and the acceleration that object would undergo.